Hello dear students, this is your engineering mathematics 3 lecture. Today's topic is Laplace transform. In last lecture also we have discussed Laplace transform of some standard functions and properties of Laplace transform. Also we have discussed few examples on Laplace transform. Here in this lecture also we are going to discuss few examples of Laplace transform. See the example here. Find the Laplace transform of integration over 0 to t sin t upon t dt. Now, Laplace transform of integration over 0 to t sin t upon t dt. How to find this Laplace transform? First, you find Laplace transform of sin t. Then, using division by t property, you find the Laplace transform of sin t upon t. And then using the integral property, you find the Laplace transform of integration over 0 to t sin t upon t dt. Now, here f of t is suppose sin t. Laplace of sin t. Sin t, its Laplace transform is 1 upon x square plus 1 because the coefficient of t is 1. So, Laplace of sin t is 1 upon s square plus 1. Means Laplace of sin t upon t. It is division by t property. What is the division by t property? You integrate that f of s. F of s is this 1 upon s square plus 1. You integrate it over s to infinity with respect to s. So what is the integration of 1 upon s square plus 1? It is 1 upon 1 because the value of this constant is 1. So 1 upon 1 into tan inverse of s upon 1. 1 upon 1 means 1. Tan inverse of s upon 1 means tan inverse of s. And the limits are s to infinity. Now we put upper limit infinity. Tan inverse infinity is pi by 2. So right here pi by 2 minus sign for lower limit. Tan inverse s. Replace s by s. We are getting the same function tan inverse s. Okay. To solve this integration, here we are using the formula of ds upon x square plus a square. And its integration is 1 upon a into tan inverse s by a. But the value of a is here 1. So 1 upon a. A is 1, so 1 upon 1. Into tan inverse s upon a. A is 1, so tan inverse s upon 1. So that it is tan inverse s only. Remember it. So Laplace of sin t upon t is equal to pi by 2 into tan inverse s. This is the Laplace transform of sin t upon t. Okay. And pi by 2 minus tan inverse s is cot inverse s. Now Laplace transform of integration of 0 to t sin t upon t dt. Now use here the property, integral property, Laplace transform of integral. What is integral property? You just divide the Laplace transform of sin t upon t by s. Laplace transform of sin t upon t is cot inverse s. You divide it by s only. That is Laplace integral property. Laplace transform of integral. So this is your answer here. Now next example is find the Laplace transform of e raised to minus 4t into integration of 0 to t sin 3t upon t dt. Now here in this example also, you find the Laplace transform of sin 3t, then you find the Laplace transform of sin 3t upon t by using division by t property. Then you find the Laplace transform of integration of 0 to t by using integral property. And then you find the Laplace transform of this complete term e raised to minus 4t into this integral using shifting property. Now, Laplace transform of sin 3t is 3 upon s square plus 9. Here it is 3 upon s square plus 9. Then using division by t property. What is division by t property? You integrate the 3 upon s square plus 9 or s to infinity. You integrate it. To integrate it, the integration is like this. This 3 is constant. 1 upon a. A is this 9 is a square. The square root of 9 is 3. So 1 upon 3 into tan inverse s by 3. Limits s to infinity. 3 get cancelled. And if we put upper limit infinity, tan inverse infinity is pi by 2 minus tan inverse You replace s by s, so the remove the term tan inverse s by 3 as it is after putting lower limit, and it is nothing but cot inverse s by 3. This is the Laplace transform of sin 3t upon t. This cot inverse s by 3. But here we want the Laplace transform of this integral, integration over 0 to t. That's why here Laplace transform of f of t. F of t, what is f of t? We have taken integration over 0 to t. Now you know what is Laplace transform of sin 3t upon t. It is cot inverse s by 3. And then use integration property, Laplace transform of integral. Integral means you just divide the term by s. Laplace transform of sin 3t upon t, you divide this term by s. That is the Laplace transform of integral property, integration over 0 to t sin 3t upon t. Now the complete function is here, e raised to minus 40 into integral. Now Laplace transform of e raised to minus 40 into integral term is equal to, now here use shifting property. Exponential function, and with the exponential function the remaining term is here f of t. Now use their shifting property. The coefficient of exponential function is minus 4. So you replace that s of f of s by s plus 4. So this is your f of s, 1 upon s into cot inverse s upon t. So here you replace s by s plus 4. It is 1 upon s plus 4 into cot inverse s plus 4 by 3. This is your answer. Okay. Next is evaluate integration of 0 to t cos 3t minus cos 2t upon t dt. Now your limits are 0 to infinity. So here we cannot use the Laplace transform of integral property. We can use that property only when the limits are 0 to t. Okay. Let f of t is equal to here. You assume that when limits are 0 to infinity, in that case, the function inside the integral is f of t. Cos 3t minus cos 2t upon t is function. Now you first find Laplace transform of cos 3t minus cos 2t. It is equal to, what is Laplace transform of cos 3t? It is s upon s square plus 9 minus, what is Laplace transform of cos 2t? It is 2 upon s square plus 4. Okay. Now use division by t property. So here there is one correction, that here there is one correction here is root of x division by t. So Laplace transform of cos 3t minus cos 2t upon t is equal to integration over integration over s to infinity s upon f of s is this function. Now s upon s square plus 9 minus s upon s square plus 4, integrate it with respect to s. This is division by t property. Now you integrate this term with respect to s. The integration of s upon s square plus 9, the derivative of s square plus 9 is 2s. If you multiply and divide the term by 2, here it will be 2s. 2s means derivative of s square plus 9. So derivative is adjusted in numerator. So its integration is log of s square plus 9 minus, same for second term, multiply and divide the term by 2. So in numerator the term is 2s. Derivative of s square plus 4 is 2s, which is adjusted in numerator. So the integration of 2s upon s square plus 4 is log of s square plus 4. This is the formula of integration. When derivative is adjusted in numerator, derivative of denominator is adjusted in numerator. The formula is this one, 1 by 2, because we have divided and multiplied the term by 1 by 2. So 1 by 2 constant for both the terms and limits s to infinity. Now we can write log of a minus log of b as log of a upon b. So a is a square plus 9, b is a square plus 4. So we can rearrange the term like this. Now when we put upper limit infinity, the term is 0, because here if we take s square common, the term is 1 plus 9 upon s square. Here also we take s square common, so term is 1 plus 4 upon s square. S square get cancelled, and if you put s is equal to infinity, the term is log 1, it is 0. Okay, minus, when we put lower limit s, If we replace s by s, then we have the same thing, log of s square plus 9 upon s square plus 4. To absorb this negative sign, we just change the numerator and denominator. The log of s square plus 4 upon s square plus 9 into 1 by 2. So this is Laplace transform of cos 3t minus cos 2t upon t using division by t for property, division by t formula. Okay. Now we want Laplace transform of this integration. Laplace transform of integration, sorry, not Laplace. We want the value of this integration. Integration over 0 to infinity. Inside the bracket, the function is there. So using the definition of Laplace transform, using the definition of Laplace transform, Laplace transform definition is integration over 0 to infinity e raised to minus t f of t dt is equal to Laplace of f of t. This is the definition. Now what is f of t? F of t is this function, cos 3t minus cos 2t upon t dt is equal to, what is its Laplace transform? It is 1 by 2 into log of s square plus 4 upon s square plus. This term as it is. Here we are using the definition of Laplace transform. This is the definition, means integration over 0 to infinity e raised to minus st. F of t is this function here, so replace it by this. It is Laplace of f of t is this RHS. Now you compare this integration with this one. With this one. Here exponential function is absent, means its value is 1, then the bracket term only. Now how to make it 1? When the value of t is 0, sorry, we cannot put t 0 because t is variable. When the value of parameter s is 0, e raised to 0 is 1. So put s is equal to 0 in this integration. So that we will get integration over 0 to infinity. Exponential function value is 1. Cos 3t minus cos 2t upon t dt is equal to 1 by 2 into s is 0. So log of 4 upon 9. 1 by 2 log of 4 by 9 means 2 by 3. And so this is the answer. Okay. So this is the example of Laplace transform. These are the examples. Here we try to solve these examples of Laplace transform. So this Laplace transform example, and over here. Next lecture we are going to discuss inverse Laplace transform. Thank you.